All right, so let's talk about TypeScript. As you can see, according to GitHub, no one knows more about coding than GitHub. TypeScript is getting very popular, right? So I expect it to just grow over the next years. So TypeScript is the first serious approach in JavaScript to types. You know, JavaScript, like other languages, for instance Python, are loosely typed languages or dynamically typed languages. That means you can create a variable, let fruit equal apple, and fruit is a string, but suddenly you can reassign the value of fruit. Fruit equals 24, and now fruit is a number. And then you can do fruit equals object, or fruit equals array, or fruit equals function. Yeah? You can change the type of your variables. You can do the same thing with Python, but you cannot do the same thing with languages like Java or C#, because Java, C#, C, these are strongly typed languages or statically typed languages. That implies once you declare a variable, it remains with that type forever. Yeah? You get married with that type and you cannot divorce from it. Yeah? So, what is better? What do you think is better? Is it better to have a statically typed language or a dynamically typed language? Do you have any opinions about that? I think nothing is better or worse, right? There are pros and cons, advantages and disadvantages. Yeah? The reality says that once you get used to strongly typed languages, for instance, Java developers, they historically speaking struggle a lot to work with JavaScript. They feel naked. And vice versa. If I now start doing Java, it's like, oh, what the hell? Yeah? So it's definitely different coding style. Yeah? To me, we can do analogy with the dichotomy of freedom versus security, talking about social rights and everything, right? This is now very trendy. So, you know, usually some people defend that it's better to have freedom in life, to do whatever you want. And some people, especially conservative people, says, rather than freedom, I prefer to have security, right? So that's pretty much the same analogy. Freedom, you can change the types. Security, you cannot change the types. Yeah? Even though the JavaScript community, historically speaking, accepted being a dynamically typed language, it is true we cannot ignore the advantages of having types. The main advantage is control. Yeah? A dynamically typed language can be broken easily. Why? Because no one is controlling your types. And because of that, even though there have been some attempts in the past, including React, so React has something called prop types, you may have heard about that. So if you came across prop types, it was the first attempt to add some sort of control over what sort of props your component accepts. But TypeScript goes one step beyond. So TypeScript has nothing to do with React necessarily. So TypeScript goes beyond the scope of React. It's about JavaScript. So TypeScript is the first attempt to add types to JavaScript. And one of the reasons why it became so popular is because it's backwards compatible somehow with what you have. In other words, yes, you can have types, but you can have optional types. So that means if you are running an app in production with, like Codery, 80,000 lines of code, if I install TypeScript on it, do I need to change everything? That will be a no-go for me, right? Like, oh, I don't want to change 80,000 lines of code just because of TypeScript. Thankfully, with TypeScript, you can be a bit more flexible. Yeah, you can make TypeScript optional. So that means that whatever was there, just don't check it. If it doesn't have any types, if it's wrong, leave it. But at least on the new stuff, I can start adding types. So on my new components, I can have that security, right? So I think it's a good balance. So TypeScript was first introduced by Microsoft like 5-6 years ago, and once again, it's getting very popular. I have the theory, even though that's not a very strong theory, that maybe one day, in the next maybe 10 years, TypeScript will be sort of part of JavaScript. It will be finally incorporated because I see many advantages and I don't see any disadvantage. If I can use it optionally, what's the problem, right? Cool, so let's do a bit of TypeScript. Thankfully, start working with TypeScript today is very easy. When I created code, it was much more complicated in regards to our React applications. So I got, not here, somewhere, hopefully I can find it, I got a very simple React application. All right, so this is a very simple React app. So now if I go to the web browser and I type localhost, not localhost, free, okay, let me stop the server. Should be running, but just in case, let me stop this. No, sorry, it's not running, sorry, my fault, I stopped it. So let me start the server and let's just prove that this is a normal React application. So what I'm going to do is to install TypeScript on top of my existing React application. Why? Because this is essentially where you are. You already have some React applications, you got your portfolio, you got Codeflix, you got your team apps. So I would like to invite you to add TypeScript. Not sure if you remember, but last Friday, I had some problems dealing with front-end, back-end. The front-end didn't start anymore. Yeah, I just realized this morning that I couldn't create React apps anymore. Something was broken with my create React app system. So I uninstall it. I hope you know how to install and uninstall, right? So let me show you. So you're in the terminal. So when you install it, a long time ago, you did something like npm install -g create React app, right? So to uninstall it, simply replace install with uninstall. So I uninstalled it this morning, I install it again, new version, and then it's all good, right? So I don't know what happened. Anyway, fingers crossed. All right, so the first thing is, how do we install TypeScript? In the past, you couldn't, it wasn't possible to install TypeScript on an existing React project. You had to create a new one, which was a bit, not ideal. But now, if you go to Google and you search create React app TypeScript, so literally if you click on the first link, adding TypeScript, and it's very simplistic. It tells you how to do it if you are installing Create React App for the first time, but if you are already, if you previously installed Create React App, which is our case, then simply run that command. npm install, blah, 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 blah. So you install TypeScript and some dependencies. So let me do that. Let me copy that command and let me paste it. And then what's next? Next, rename any file to TypeScript. For instance, index.javascript to index.tsx. So generally speaking, TypeScript files had the TS extension. But because we're working with React, some React files, they have JSX extension. So now TSX, that means that's a React file that supports TypeScript. All right, so let's do that. On our navigation panel, I'm going to rename app.js, which is my hello world component, right? So if I rename the file from app.js to app.tsx, you see Visual Studio Code. Not sure if you can see the React logo, but it's still it's aware that this is still a React file, even though it doesn't have the JSX extension anymore. All right, so that's it. Look, I just renamed the file. Let's start the server. So if the theory is right, everything should work, right? I just installed TypeScript, so nothing. Look, you still get some updates here. Not sure if you got that. But the first time we ran the npm start, it did some stuff under the hood. For instance, created some files, including a TypeScript config file. We'll see that thanks to that file, we can customize the behavior of our application. We'll see that in a minute. For now, does the app work? Yes, it works. Cool. So let's start adding types. Imagine that I want to change the title. instead of edit, source up, and save to reload, I want to say welcome to TypeScript, right? So can we create a function welcome to TypeScript that returns welcome to TypeScript, right? So now, can you tell me, guys, how do I replace that hard-coded line with a call to the welcome to TypeScript function? Curly braces, props, no, this dot,
I know this is a functional one, so you just do welcome to TypeScript and then invoke.
like that,
And you got it invoked the function.
like that.
Yeah, maybe. Yeah.
That's pretty fundamental, right? If you disagree on that, you can disconnect from this workshop and focus on React basics, right? Because that's pretty fundamental, right? You have a function and you invoke it. Cool. So, will that work? Yeah, welcome to TypeScript. Nice, fantastic. So imagine that we want to say welcome to TypeScript and then the name of the user. So for instance, Peter. Welcome to TypeScript, Peter, right? So can I pass an argument here? Yeah, and then what? No, sorry, before going that far, no, sorry. Let me change my mind. Before passing any argument, I want to start using TypeScript. I want to make sure that my welcome to TypeScript function returns a string. I want to avoid things like that. That's an array. I don't want to do that. Why? Because that's a bit weird, right? Or what if I pass an object? Can I pass an object? That's a weird welcome message. Probably, look, that doesn't even work, right? You cannot display an object in React. That doesn't work. So let's ask TypeScript to help us. So to prevent from these situations, let me put back the string, we can tell TypeScript, hey, this function has to return a string. And how do we do that? Look at the syntax. Colon, string, after the parentheses. So that is specifying, it changed color, as you may have noticed. Now it's sort of green or blue. Now we are forcing our function to return a string. Yeah? So if it's a string, it works. What happens if it's not a string? Once again, if by accident I'm refactoring my code and I don't realize, but I type something like that, which is wrong, right? First of all, few things. Look, Visual Studio Code is immediately highlighting the line. That's new, right? Without that, it didn't happen. So that's fantastic. Immediately, hey, that's wrong. If because of whatever reason you don't spot that, look, the server complains. Yeah? Type blah 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 is cannot be assigned to type a string. And it's even give you the error code. So you can go to Google and get some literacy about it, right? And even if you ignore that message as well and you go back to the browser, it throws an error. You see? That's the way you can control the quality of your app, by checking the types. All right, so we got the type string. So now, once we fix it, then everything should work, compile successfully, right? So back to the browser, and then it works. So now let's talk about arguments. So once again, I want to say welcome to TypeScript and then the name of the user. So, Peter, right? Look, it's complaining already. Why is it complaining, guys? About passing an argument, Peter. Correct, because the function doesn't have any argument. So you see with TypeScript, it's checking in real time that your data flow is accurate, right? All right, let's pass here name, for instance. Name, name, something like that. Look, the error is gone. But look at the error, failed to compile. Can anyone tell me why that snippet throws an error? Never use the argument. All right, okay, I'll get that, Gideon. Let's have the argument. Still failing. Why?
Welcome to TypeScript is already a string.
Yeah, and then what? We're still returning a string, so that's fine. The problem is, we got how many arguments do we have? One. What's the type of the argument? It's a what? It's not a string.
It could be a string or anything.
That's correct. Could be a string or anything. Are we explicitly telling our system, hey, the argument of my welcome to TypeScript function must be a string? Are we telling that information? No. No, that's why it fails. Look. Parameter name implicitly has an any type. Any is like a wildcard in TypeScript, like A. If you don't set any type, the type is any, could be anything. But by default, TypeScript doesn't like that, by default. Yeah, that means that fails. Yeah, look at the error. The error is really good, right? It's pointing to the exact line and column where it fails. All right, so how do we add a type to the argument? Call a string. Oh, sorry, no string literal, like that. You see, and now if we compile, boom, compile successfully. Yeah? So the way we add arguments, add type, is always the same. If we refer to an argument, colon, and then name of the argument. If we refer to the return statement, the same thing, colon, and then the return statement. Yeah? Any questions so far?
You always have to, if you specify the type that you want the function to output, do you necessarily have to specify the type of the argument?
By default.
So do they have to match or not?
Yeah, of course they have to match, right? Look, what happened? What happened, guys, if I pass a number? If instead of Peter, I pass 69. Look, it's complaining already. Before compiling, you see, just Visual Studio Code say, no, this is not going to work. Statically checking the type, right? Argument of type 69 is cannot be assigned to parameter of type string, which makes sense, right? So yeah, of course, it's checking if that's right or not. So, yeah.
I mean, like, for example, can you have a situation where your argument is one type, but your output is supposed to be another type?
Well, yeah, of course. Yeah, let's do that. So what if instead of name, we want to pass the H, which is a number? Yeah. Well, that's absolutely valid, right? Well, it failed to compile. Why it failed to compile?
I mean, if you did something like, for example, like, if age 12 name equals whatever, and then like had something in your function where it validated the number.
I'm not following you, Sarah. You can definitely have different types. And now it's failing, and I think it's failing. Correct. Because I didn't replace that, right? But if we do that, you see, now it works. So you can definitely have multiple types. Let me go back to the name scenario. That's a scenario I showed you before that has an issue. If that throws a problem, that means that if you are already working with React and you install TypeScript, it's going to blow up 2,000 times. What happened with all your existing functions? By default, that's what you have, right? You remember what I told you before? That we can make TypeScript optional. So that's a good example. I don't want that to fail. Again, if I start a new project today, of course, I create my first line of code using TypeScript, blah, 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 whatever. But if I have a running piece of software, I want to be backwards compatible, because otherwise I'll give up. I won't proceed with installation. I cannot afford spending 1 month of my life just adding types to everywhere, right? Cool. Thankfully, there is a way to tell TypeScript, hey, you know, be a bit more flexible. So I told you before that when you install TypeScript, it created that file, tsconfig. Here is where we can specify the behavior of TypeScript within our application, how strict it's going to be. And there is a property that I'm talking may not be completely accurate. If it doesn't work, I'll go to Google. As part of the compiler options, you can pass a property called no implicit any. So if you add that property, no implicit any, and you set the value to false, that means now I think we need to restart the server, right? When you do changes on the tsconfig, you need to restart the server. So if I remember correctly, thanks to that, now the any type will be allowed. Let's see if it works and then we'll explain it. Still starting, just give me a second. Yes, it works. Yeah? So definitely that's the right option. So what that means? By default, that property has value true. It's a bit hard to read because it's negated. No implicit any true. That means you are not allowed to have implicit types. Yeah, it's a bit confusing, but if you think about that, it's logical. It's like German. It's complex but logical. No implicit any by default is true. So you cannot have implicit types. But if you said no implicit any false, that means that you can have implicit any. Does it make sense?
Yeah, but isn't it a situation where the file types which have TSX are the ones which have TypeScript? If you have a file type which is just JS.
Correct. Yeah. Correct. That's also a valid point, right? So if you don't rename the extension to TSX, the file won't be evaluated. Yeah. So that's a good point, actually, Sarah. So you have these two approaches. Either you stop renaming the file extension, or you add the file extension and you add the no implicit any, right? So you have the two approaches. The main goal of that property is to be way more relaxed. Yeah? So you can start migrating. What happens if, for instance, you change the extension of a file, but then it's a big file, so you want to keep working and progressively add types to that file because in real life, on an ideal world, the file should be small enough, so you should be able to adapt or convert the file in one go, but that may not be realistic, yeah? So I'm just trying to explain the different scenarios. So once you got that, now essentially you can do whatever you want. Does that mean that I can break it? So can I return a number? Will that work? Clearly not. So no implicit any doesn't mean you can do everything. Yeah? That means that you are allowed to avoid the type on that particular variable. But if you add the type, of course the type must be correct, must be strict. Yeah? All right. So we got name, string. Let's pass the age of the user. Yeah? So now, as you can see, it fails, because now our function is receiving 2 arguments. However, according to the signature of the method, we only have 1, right? So we need to pass the age. Will it work like that without specifying the type of the age? Why? Thanks to that not implicit any, we are allowed to do that. That's why it works. Yeah? But once again, if we are creating that function from scratch, let's complete it, right? So will it work like that? H string? Clearly not, right? What should we put here? Number. Yeah, compiled successfully. So that's pretty much the way TypeScript works. I would like now to do a bit of training using the platform. Not sure if you've played a bit with it already. We're adding some changes on the UI, by the way. So TypeScript. So first of all, let's talk about strings. There's a couple of questions. New interface, by the way. You cannot see the last option, I'm afraid. My face is on top of it. So concatenate, what's the right option? A, B, C, or D? D? B. What do you think? Let me try to move my face. I cannot, sorry, I cannot move my face. Sorry about that. So, B, do you agree, guys, or not? Yeah?
Yeah.
Let's try it. That's correct. You got confetti, right? One more, and then I'll show you another more complicated example. So, here you go. So concatenate two strings. What's the right option here? Still B, Gideon?
Yeah, still B.
Still B? Anyone disagree on that? No? What about the second scenario? What's the right option? Which one, Sarah? A? What do you think? Yes? All right. Will that work? Yes, it works. One more. Last one. That's a bit more complicated. Let's read the instructions. So we have a function that receives something and returns something. A, because we receive a string, and then what? What do we return? D, that you cannot see, right? Because it's column number. That's correct. Some people say, hey, TypeScript training is too easy. It's true, it's too easy. But that's a good thing, right? It's because TypeScript is easy by definition. So we've been talking about primitives, strings, numbers. You can imagine booleans, for instance, the same. But what if we want to deal with more complex data structure? What if we, for instance, if our function says is a student certified, receives an object, name, average score, email, with more complex data structure. So let's do more complicated training. So in TypeScript, we've got something called interfaces. So an interface is essentially an object, yeah? An object that you can specify which properties exactly your object should contain. So interfaces. Oh, it's locked. Thank you for nothing. All right, I cannot show you in production, but because I played before. But let me go back to my local environment, and hopefully I can show it to you from there. Hopefully. All right. So. All right. So training. It's TypeScript and then interfaces. Here we go. All right, so how the problem looks like. In the first case, we receive a tennis player, which is an object, with first and last name. And we want to create a function that obtains the first name out of that object, right? So look at how interfaces look like. Yeah, so an interface is essentially something like an object where you specify, given a variable of type iPlayer, it must contain first and last name. Yeah? All right, so what's the right option? A, B, or C? B, D, Mountain, D for Denmark, B for Bravo. Let's have a look. It's a bit slower because it's running on my machine, but hopefully it's very slow, right? All right, it's not B. Let's see what's going on. I think it's just timeout, guys. I think my machine is very slow. Let me, sorry about that. Let me sign in with a different user in the Codiri platform. I think that will simplify things a bit. Sorry about that. All right. Here we go. So once again, TypeScript interfaces. Here you go. By the way, now you can swipe anywhere on the screen. You are never going to have scrolling issues because, as you can see, the code is wrapped. Yeah? So if a line cannot be allocated, it's moved to a new line. So you can now safely swipe left and right from anywhere. All right. So you said option B, but now it has changed. So option B now is option A. You agree with me? We receive an argument player of type. Is it a string? No. Is it a Boolean? No. Is it a number? No. It's type of interface. Interface I player with capital P. And you can see that now it works fine. Yeah. All right. Let's have a look to question number 2. So what we got here? We, once again, it's very similar, right? We have an object, and we once again want to return the first name of the object. The main difference is the object has a different shape, different structure. Now we got a root name key that contains the first and the last name, and we also have the age of the player. Yeah? It's a slightly different object. So, first of all, you see, that example is really good because here you can see how to nest interfaces. So an interface can be part of another interface. That's a good example. iPlayer, yeah, that's the root interface. We got name and age, but the name itself is likely to be another interface. Yeah? So that's the way we can nest interfaces. So first of all, what's the interface of the player? A, B, C, or D? D for Denmark?
Yes.
You cannot see anything here. No, sorry about that. But yes, iPlayer. Yes or no? Yeah. And what about here? What's the type of name? D for Denmark? A? A? Yeah, because we got the column already, right? So start paying attention to detail. All right. Let's see if it works. Confetti time, right? And then option, question number 3, get personal details. So here we have an object, once again, but instead of returning a string, we want to return another object. So we receive probably an interface, and we want to return another interface, which makes sense, right? Sometimes you want to return objects. All right. So what's the right option here? That's a bit more complicated. Which one, Gideon? B. All right, so according to Gideon, our function receives a driver, and it returns with whatever properties the driver has, and it returns literally the same. Do you agree with Gideon? All right, let's leave it there. And then what? You said C? B? That's very complicated, right? This is one of the most complicated scenarios you can get. All right, yeah, that's B makes sense. All right. So let's read it top to bottom. So first of all, on the first case, look, that I don't really think that's correct. Why? Because driver is of type iDriver, yeah? So that thing here. But it returns something different. It returns driver dot personal, yeah? So definitely there is something missing here. So what is type personal? First of all, we can ignore C and D because they don't have any column. So syntactically speaking, C and D are wrong. So now it's between A and B. I would say that the right option is A. Why? Because A personal details, yeah, is a different type of data. In other words, personal should be of type iPersonal details. All right. About the second scenario, yeah, I think I'm not convinced. I got a feeling that there could be a bug in the platform. Why? Because after personal, or maybe it's here, right? I think there is some missing text because none of these answers really make sense, I believe, right? Let me select it. You see, look. Once I selected personal, now it makes more sense, right? But that's wrong because there is some missing text here. So that's a glitch in the system, right? I added that yesterday, so sorry about that. But once I selected option A, I hope you agree with me, now it makes much more sense, right? Let's recap. So get driver details. It receives iDriver, that object, that interface, right? And then it returns driver.personal. So what type driver.personal is? iPersonal details. That's why this is what it gets returned, right? Yeah. And then it works. Any questions? Yeah, so that was a bit dodgy, to be honest. All right, so let's see if next one works fine. So let's talk about movies. We have a function getMovie that receives a query, and based on that query, it returns some details. So for instance, if the query is, give me a movie, which director is James Cameron, and the year of the movie was 1984, the system will return the details of the movie, title, whatever, budget, yeah, whatever. Yeah. So obviously the algorithm is not relevant in this case, it's just about the types. So first of all, the query. What's the type of the query? D. iMovie.
Oh, no, sorry, it was A. I'm trying to remember what the question was.
I.
A? Yeah. Did you put a query?
You can see that even if we don't remember the questions, if we play a bit with the semantics, if the variable is called query, the type should be iQuery, right? But once again, this is because we did some efforts trying to provide meaningful semantics. Yeah. All right. So query is type iQuery. So that means that whatever the object is passed, it should contain these two properties, director and year. And what the query returns. Yeah, it's the, even though you cannot see that, right? Please, next time I'll remember to get rid of my face. Yeah, it's iMovie. Are you sure? Why not? Colon. Yeah, look at what happened. Colon is twice. So then it should be C. Yeah? Let's see if it works. That's correct. Cool. How many questions we got left? I think it's one or two, right? Yeah, that's the last one if I'm right. So now, once again, let's talk about movies. So now our function receives the director of the movie, and then in theory it should returns it should return a movie of that year, something like that. I'm not fully convinced about that. All right, look, yes, so it receives a query, which is a string. So it's like a free text search, right? Like Google. Google, you search some text, you type some text, and then it searches based on that query. All right. So now, this is all about defining the interface. So, first of all, let's talk about the title. So what's the type of the title? A, B, C, or D? A. Title is just a string, right? And now, our system has a Boolean that determines, like Rotten Tomatoes, if the movie is any good or not, right? So, once again, let me select it and then you tell me if it's right or not, because you cannot see that. Is D? Why D and not B, for instance? Correct. It's good. It's a Boolean. Yeah? So then you can see how Booleans look like in TypeScript. And then it works, right? So that's pretty much it about TypeScript. If you want a very strong suggestion, install it now on all your apps. Why? Because nothing is going to break, right? Install it now, and then from now on, whenever you create a new piece of functionality, you can use it. You're going to learn it for free. It's very easy to play with it. I noticed the power of TypeScript a few years ago. I introduced it at HSBC. I remember one day we had, because of whatever reason, to refactor hundreds of lines of code. We had to change everything. And after changing everything, I remember we ran TypeScript, and they said, like, you got like 20 errors. And it was like, okay, that's good. Because some of these mistakes, it couldn't have been possible for me to detect without an automated tool like TypeScript. Like in that function you've changed, before you were sending a string and now you're sending a number, like, oh yes, that's true. It prevents you from having big issues in production, right? So definitely where you see how much TypeScript pays off is when you refactor, when you move things around, because you can refactor things very quickly. Okay? And coding is about refactoring, changing, moving things around. Any questions? No? All right, so that was it, guys.